Hello, and welcome to the next video on trigonometry. So far we have spent our time focusing on right triangle trigonometry, meaning we've been dealing with angles which are less than 90 degrees. Of course, these are the angles that exist inside of a right triangle. Now, we've talked about trigonometry being the study of triangles, specifically right triangles. But what a lot of people don't know is that trigonometry is actually based off of a circle. So you may be asking yourself, how does a right triangle relate to a circle? Well, let's say I were to give you an angle. Let's say I were to give you right here 20 degrees. Where's the right triangle? Well, the right triangle would be if we bring the other leg coming down from the top of the circle straight down to the x-axis. And here we get our right triangle. And this angle right here would be 70 degrees. And there we have our right triangle with an angle of 20 degrees. So in this video, we're going to be talking about non-right angle trigonometry. Meaning, what do we do when we get an angle which is not between 0 and 90 degrees? How can we deal with that angle? So let's take, for example, 120 degrees. That would put us right here in the second quadrant. This is 120 degrees. Where's our right triangle? Of course, this doesn't make sense. That would not be our right triangle because that's not a right triangle. An angle that's greater than 90 will never exist inside of a right triangle. So, same thing that we did here in the first right triangle, we're going to bring one of the legs down from the circle straight down to the x-axis. Notice right now we have a right triangle. So when we're working with 120 degrees, in reality, we're going to be referring to this right triangle here in green. So the angle that we actually want to work with is this angle right here, which would be 60 degrees. 60 degrees in this case is called the reference angle. And it's called the reference angle because that is the angle that we will be referring to when we're trying to find the trig function of an angle that is not between 0 and 90 degrees. So let's take a moment to discuss what a reference angle is. Here is the technical definition of a reference angle. A reference angle is the smallest positive angle formed by the terminal side and the x-axis. It will always be an angle between 0 and 90 degrees, or 0 and pi over 2 radians, depending on which units you're working with. So let's take, for example, 150 degrees. Let's say that we want to find the reference angle to this angle. So 150 degrees is an angle that exists in the second quadrant, somewhere around here. So if we take a look at the reference angle, it's going to be the smallest positive angle formed by the terminal side and the x-axis. Therefore, this angle right here is the reference angle. And that's pretty easy to calculate. All we need to do is get 180 minus 150. And that would be 30 degrees. Therefore, 30 degrees is the reference angle to 150 degrees. Now let's take 207 degrees. What would the reference angle to this angle be? So 207 degrees would be somewhere here in the third quadrant. Notice the terminal side lies in the third quadrant. So, taking a look at the definition of a reference angle, the only angle that makes sense is this angle right here. And that's actually, again, a very easy angle to calculate. All we need to do is 207 minus 180 degrees. Very easy. And therefore we get 27 degrees. Therefore, 27 degrees is the reference angle to 207 degrees. Now you may be asking yourself, what's the purpose of the reference angle? You will see a little bit later in this video why this is so important. Now let's take, for example, 315 degrees. What would the reference angle to 315 degrees be? So 315 degrees would be right here in the fourth quadrant. That's 315 degrees. So once again, looking at the definition of a reference angle, the reference angle would be this angle right here. And that's, again, very easy to calculate. All you need to do is 360 minus 315, which would be 45 degrees. Therefore, 45 degrees is the reference angle to 315 degrees. Let's do one more. How about negative 50 degrees? So negative 50 degrees is in the fourth quadrant. This is negative 50 degrees. But this may seem a little confusing, but remember, the key word here is the smallest positive angle formed by the terminal side and the x-axis. So the reference angle to negative 50 degrees is actually 50 degrees, positive 50 degrees in this case. So now, given any angle, you should be able to determine the reference angle to it. And remember, if you're working in radians, you're going to want to continue working in the units, radians, as well. So pause this video and try to find the reference angle to these four given angles. When you unpause the video, the answers will show up in a few seconds. And there you have it. Here are the answers. Notice the last two, numbers 3 and 4, would probably be the hardest. So let's try to think about the last two real quick. So when we're given 9 pi over 7 radians, that means we've moved pi over 7 9 times. So 7 pi over 7s would be half a revolution, right? This angle here is 7 pi over 7s. So 9 pi over 7 means we moved 2 additional pi over 7s past half a revolution. So how many pi over 7s did we pass over half a revolution? Twice. So that would be 2 pi over 7 radians. And you could confirm this would be a positive angle, which is between 0 and 90 degrees. And the last one, number 4, is also a little bit tricky as well. So negative 130 degrees is here in the third quadrant. Our reference angle would be this angle. So the way I determined this was essentially I just did 180 minus 130. And that would be 50 degrees. And that's my reference angle. So I hope that helped a little bit in understanding how to figure out reference angles. Now, here's the purpose of understanding a reference angle. Let's say I gave you this problem here. Sine of 120 degrees. So if you remember what sine represents, this means that we're going to get the opposite over the hypotenuse of a right triangle with this given angle. However, it is impossible for a right triangle to exist with an angle 120 degrees. How can we figure this out? So let's try to determine what 120 degrees looks like in standard position. So 120 degrees is right here in the second quadrant. Now, like we said before, our right triangle will always have one of the sides on the x-axis. Therefore, this has to be the right triangle. So what we're going to be doing is, even though we're given an angle bigger than 90 degrees, we are going to refer to this triangle right here. So the angle that I actually want to work with in this case would be the reference angle right here, which if we calculate, that would be 60 degrees. Now, notice here that the opposite side is above the x-axis. Therefore, we can say that this here has a positive side. And the hypotenuse is always going to be positive. So really, in order to figure out sine of 120 degrees, all we have to do is, it's going to be the same exact value as sine of 60 degrees. And that's an angle that we should know. That would be square root of 3 over 2. Again, because that is a special angle, so we should know the exact answer because of the special right triangle. However, something different is going to happen if I was now asking for cosine of 120 degrees. Now, if we're looking at 60 degrees here, if we're referring to the reference angle 60 degrees, notice the adjacent side over here, which I'm drawing in red, is actually to the left of the x-axis. If you remember your x and y coordinates, anything to the left of the origin is going to be negative. So actually, the adjacent side now is a negative side. So what we're going to want to say then is cosine of 120 degrees is going to be the same answer as cosine of 60 degrees. However, it's going to be negative instead. And cosine of 60 degrees is half, so cosine of 120 degrees is negative 1/2. So when you are given angles greater than 90 degrees, the trig functions may be negative depending on which quadrant the terminal side of the angle is on. Let's do one more here. How about tangent of 120 degrees? So the opposite side to the reference angle 60 degrees is positive, but the adjacent side is negative. Therefore, because tangent is opposite over adjacent, the final answer is going to be negative. We get a positive divided by a negative, which is negative. So this is going to have the same value as negative tangent of 60 degrees, which would be equal to negative square root of 3. And of course, the reciprocal trig functions are just the reciprocal of these answers. Now, let's take a look at all right triangles. In the first quadrant, a right triangle would look something like that. In the second quadrant, a right triangle would look something like that. In the third quadrant, the right triangle would look something like this. And in the fourth quadrant, a right triangle would look something like that. Notice that one of the sides will always be on the x-axis. This is a very important rule to know. So notice in the first quadrant, both sides of the right triangle are positive. In the second quadrant, the opposite side to the reference angle is positive, but the adjacent side is negative. Therefore, the only positive trig function would be sine. And of course, its reciprocal cosecant. In the third quadrant, both the adjacent side and the opposite side to the reference angle, which would be this here in blue, both the opposite and the adjacent side are negative. Therefore, if you think about it, the only positive trig function would be tangent, because a negative divided by a negative is positive. So tangent and its reciprocal cotangent are both positive. Sine and cosine would both be negative, as are their reciprocals. And finally, in the fourth quadrant, here, the adjacent side is positive, but the opposite side would be negative. Because notice, again, the opposite side is below the x-axis. So if you're looking at the y-axis, when you go down, that side would be negative. Therefore, the only positive trig function here would be cosine, because adjacent is positive. And in all of these, the hypotenuse is always positive. So really what's determining the sign of the trig function would be the opposite or the adjacent side. So in the fourth quadrant, cosine and its reciprocal secant would be positive. Now, this may seem a little bit overwhelming, but I'm going to show you a little trick here that you should memorize. So if we're looking at a Cartesian coordinate, going from the first to the fourth quadrant, you want to remember this. ASTC. A quick mnemonic device to memorize this is all seniors take calculus, or all students take calculus, however you want to remember that. What this represents here, what these letters represent, is which trig function will be positive in that quadrant. So, in the first quadrant, all the trig functions are positive. All of them, sine, cosine, tangent, and of course their reciprocals. In the second quadrant, only sine is positive and its reciprocal cosecant, but the other four trig functions are negative. In the third quadrant, only tangent and its reciprocal cotangent are positive, and all the others are negative. And finally, in the fourth quadrant, only cosine is positive and its reciprocal secant, and all the others are negative. So this is a really good way to help you remember, if you are given an angle and you know which quadrant the angle is located in, you will know the sign, meaning positive or negative, of your final answer. So let's take, for example, if we wanted to find sine of 225 degrees. Okay, so of course there's no such thing as a right triangle with the angle 225 degrees. So we want to look at the right triangle that we're going to refer to instead to figure out this answer. So 225 degrees puts us right here in the third quadrant. If we take the time to calculate the reference angle, or the angle that we want to refer to, this would end up being 45 degrees. So notice we end up getting this right triangle here, which happens to be the 45-45-90 triangle. So, because of my mnemonic device, all seniors take calculus, I know that only tangent would be positive in the third quadrant. So sine is not tangent, therefore I know that this is going to be the same thing as negative sine of 45 degrees, which would be negative 1 over square root of 2, or negative square root of 2 over 2, whichever way you want to remember that. You can confirm that on a calculator. If you type in sine of 225 degrees, you are going to get negative 0.707. And, 1 over square root of 2 is approximately 0.707. So if you were to plug into a calculator sine of 225 degrees, you are going to get negative 0.707. However, if I was looking for cotangent of 225 degrees, well, I know cotangent is the reciprocal of tangent. Therefore, if tangent is positive for an angle in the third quadrant, then I know this is going to be the same thing as positive tangent of 45 degrees. Again, in order to find the actual ratio, you have to refer to the reference angle. And I know that this will be 1. And you could confirm that for yourself on a calculator. Again, because the opposite side and the adjacent side are both negative, therefore a negative over a negative would be positive. And because this is a 45, 45, 90 triangle, both the opposite and adjacent side are the same length. Therefore, we get the answer 1. Let's do one more. Let's say I wanted to find tangent of negative 30 degrees. So negative 30 degrees is an angle here in the fourth quadrant. So the reference angle is actually going to be 30 degrees. So notice that my reference right triangle would be this one here. And this happens to be the 30, 60, 90 triangle. Therefore, if I remember my mnemonic device, in the fourth quadrant, only cosine is positive. But because we're looking for tangent of an angle in the fourth quadrant, my answer is going to be negative. So this is going to be the same answer as negative tangent of 30 degrees. And this would be equal to negative 1 over square root of 3. Or negative square root of 3 over 3. Depending if you prefer to rationalize it or not. Now, if you were asked to find, for example, cosine of negative 30 degrees, well, for an angle which is in the fourth quadrant, I know my final answer is going to be positive. So this would be the same thing, the same answer as cosine of just 30 degrees, which would be square root of 3 over 2. And again, you can confirm that on your calculator if you want to. So at the end of the day, it's a very simple two-step process when you're working with an angle that is not between 0 and 90 degrees. First things first is you want to determine what the reference angle is. And the second step is to determine the sine of answer. And this you determine with the trick all seniors take calculus. And remember, these represent which trig function is positive in which quadrant. And of course, the reciprocal of these trig functions would be positive as well. And that's it. That's all you have to do. It's a very simple two-step process. Now, to wrap this video up, try to solve these trig functions on your own without the use of a calculator. Now, the only time that I will tell you not to use a calculator is because these angles, believe it or not, will refer to one of the special angles, 30, 45, or 60. However, if you are going to be working with angles that are not special angles, which are not 30, 45, or 60, or do not refer to those angles, then you will need a calculator. And you actually will not really need to simplify anything. You could just plug it directly into a calculator. But for problems where you are not to use a calculator, it is most likely going to be because these angles will refer to one of the special angles. And therefore, you should know how to calculate those given the special right triangles. So, pause this video and attempt to do these problems on your own. Remember, break this down into the two parts to determine what the sine of the final answer is and to figure out what the reference angle is. And then finding the final answer is going to be very easy. So pause this video, try to do the problems on your own, and when you press play, the answers will show up in a few seconds. And there you have it. Here are the answers. Now, if you want to double check your answers, you can go ahead and plug them into the calculator. However, just realize that when a calculator finds these answers, it's not going to give an exact answer. It's always going to give you the decimal version of these answers. But they should be the same exact answer at the end of the day. But the whole practice here is to try to do these without a calculator, especially if the angle refers to a special angle. Other than that, you can then use a calculator for any other angle, really. So that wraps up this video. I hope it helps, and good luck studying. See you in the next one. Bye.